Hello, I'm Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is part 2 of a series where we're going to be making a game called Boxxle or Sokoban, depending on where you know it from. We're going to be making it in GameMaker Studio 2 to get an understanding of how it's made, what it's, how to develop it, and then we're going to port it over and make a game engine using C++ and SFML, the library. So what are we trying to solve in this video? We are going to be doing the actual gameplay. So this is, for those of you as a refresher, this is what's going on with our game. So we've got a little block pushing game. The goal is to get the blocks and push them to the goal. So what kind of graphics? And they say pause this if you need to go out and get these things, but we need a floor background tile that's at least 720p resolution. So that's just so it's not just a black background, give it something, a nice feel for the ground. I'm going to need a box sprite that is 60 by 60. Please stick with these resolutions, at least for the time being, and you can change things up if you need to later. Wall 60 by 60, goal 60 by 60, and I have actual little animations for the hero so he can move up, down, left, and right. They're not the best for the time being. I spent more time than I thought I would trying to find a sprite with a person pushing and just pushing a person walking around. I could not find one, so I'll just use something from somewhere else for the time being. So that's that. So what are we going to be doing gameplay wise? We're going to allow the player to walk around when he can. Basically, if there's no box in front of him, there's no wall, he should be able to move square to square. And then same token here, if there's a box, if there's no square after that, like there's an opening for the box to be pushed, then we'll allow that to happen as well. So that's basically the only two movements that the character has in the game. And then we'll be maintaining how many steps the player takes as we progress through, solving the puzzle. And then we'll also determine the win conditions. And the win condition is there a box touching every goal? It's essentially, if you want to think of it that way, it's the easiest way to think of it. So that's the video for that part. So let's take a look at the graphics here. We'll get to there in a second here. So again, here is my 720p plus resolution for my floor tile or my floor. You don't have to scale it down or anything like that because you just need to take a portion of that image. So I don't need to worry about it. Maybe I would bring it down a little bit if I was going to put it out in the world, but for now, everything's happy. Everything's fine. Here's my 60 by 60 wall tile. Here's my 60 by 60 goal, which is just an X. Here is my box, which is 60 by 60, and then here is the 60 by 60 for my player. I broke up his animations into a left, right, up, and down sprite. So there's the left, there's the right, there's the up, there's the down. And I did go in here and make sure that I used the full image for the collision mask. That's just to prevent troubles later on down with the code. So sprite-wise, again, if you need time, I'm not going to wait here forever, because who knows how long it'll take you to make these things. But for now, that's what you need. So pause it, come back, or watch it again, whatever you need to get to where you need. These are the sprites that I'm using for this game. So now when it comes down to the object types, I have my hero. We'll talk about the code here in a second. Hero uses the hero sprite. I'm just using the down for the start of the thing. I have a box using the box sprite, a goal using the goal sprite, and a wall using the wall sprite. Don't worry about this last one. We'll talk about that in a second. And I already went into my level 1 and I just played around a little bit. And the one thing I did not do, so I just created these objects and just put them in the room. This is all testers. So I mean, obviously the game's not going to look like this once we get going, but this tests to make sure the character can move to the right when there's open spaces. He can move to the right when there's a box and no box past it, and he can't if he hits a wall or over here, or if there's two boxes, he won't be able to move. This is just the tester to make sure everything is going. The last step I need to do for the background layer is to use my background tile. Okay, it could use a little more work, but that looks halfway decent for the time being. Okay, so I have all of this set up. I basically have, I have my sprites, I have my objects, I'm ready to go. So now I can talk about the code. So I'm going to try moving to the right first. So what is that? Key press right event. Every time I press the right arrow key, I'm going to try to walk to the right. And so, in this case, like what can I do? And now, so check out this code here, this line of code. If place meeting x plus sprite width, comma y, comma solid base class equals false. So that is basically asking, if I took my object and moved over to the right one whole square and placed my object there, would it touch anything solid? And so now I discussed this, like, what does that mean? I parented wall and box to solid base class. So solid base class, all it has is the two children, as you can see here, the wall and the box. And it just simplifies the amount of code I have to write, and it actually future-proofs everything I'm going to do. Because a box is a solid object, a wall is a solid object, and so if I try to go to the right, and there's no solid object of any of those two types there, I should be able to walk, and I do, x plus equals sprite width. So that's the going theory. And the reason to also use this solid base class and parenting is if the game gets more advanced later on, the designer comes up with newer ideas, we can just parent that to the solid base class, and I don't have to rewrite any code. But if I had a bunch of place meeting with wall and place meeting with box, and then this and then that, every time I'd add a new object type, I'd have to go back and rewrite my code, and I have to change things in 2, 3, 5, 100 places. Who knows? You forget one, you have a subtle bug. So this right here handles the case where there's a person and there's nothing to the right of them. And so if this fails, all I know is that there was something solid to the right of the character. I don't know what that might be. So I have to continue on here. And so this is the setup for the moment, and I say else, and then inside of here, if, and now what? I try to move over one square, just like I did before, and I say, is there a box there? Because that's the only other way this character can move to the right, is if there's a box one square over, and that's the true part, if there's a box one square over, and then if there's nothing solid 2 squares over, because I can push the block into an empty space. So just like I did up here, it's the same basic code, checking to see that there's nothing solid, but in this case it's 2 squares over. So if this is x plus sprite width, this is x plus sprite width plus sprite width, or x plus 2 times sprite width. So I'm not moving the box just yet, I'm just testing out the movements, and then everything else can kind of come with that. So let me pull the game over here. Here's my game, puzzle 1, here's my guy, there's everything going. I press right, everybody moves. I press right, everybody moves. So they should all move here because I should be able to move where there's a box and then there's an empty space. And again, we'll fill in the detail in a couple minutes. So yep, everybody can move. And now the guy on top should not be able to go anymore because there's a box and something solid. And then now the third one from the top shouldn't go anymore, but everybody else should. And then now everybody else can continue on, and I'm jamming that right key. So it's looking good. The character is doing what I'm thinking it should do. Pretty cool. So, okay, so before we move on, let's get the animation going. Let's do all the hard work first, because what we're all we're going to be doing is changing the tediousness of all of this to do up, down, and left. So instead of just doing x plus equals sprite width, I can actually set alarm timers and speeds. So I can say direction equals 0, because I'm going to the right. Speed equals 6. Alarm 0 equals 10. So again, so what's happening? I'm 10 game frames at the speed of 6. So when 10 game frames elapse, the character has moved 60 pixels because it's 10 frames times speed of 6. So you want to make sure whatever number you choose for the speed and whatever number you choose for the timer, when you multiply them together, you get 60, so it goes the full 1 square. So when I get and when I do this also, I want to set my sprite index, because I want to change the sprite into gameplay hero right sprite. So I'm setting the animation so he looks like he's going to the right, and I'm moving him with a speed, and I'm setting him with an alarm. And so now I can add the alarm event, alarm 0. And basically all I want to do is set speed to 0, and I should also set the image speed to 0. And this is just me looking ahead, because he's going to look like he's running in place. If you don't care if he's running in place, don't worry about it. but I'm going to also say here sprite index is 1, or sprite index is 1, image speed is 1. So let's try this out. Let's see if this works. Puzzle 1. So I move. There they go. There they go. There they go. There they go. So you can see maybe the speed is a little fast for his feet, but you can see there is an animation there. So that's kind of what I wanted to do. So now I kind of want to do the same thing here for this, but I also need to start pushing the box. So as I say, there's a lot of little things going on here, and we could just kind of steal the same thing. But what one thing I definitely want to do is make it slower, because it should be more, he should be more pained that he's pushing the block. So maybe a speed of 2 and an alarm of 30. So let's see what that looks like. Oh, he's slower. Good. Slower. And so the box will be able to move at that same speed as well. So it's the same principle, but now I have to change my code up just a little slight bit here, because I need to know which box it is I need to push. So this place meeting, this function here is no longer what I need. Because place meeting function, I can look into the help here, returns a Boolean, a true false. That's great for what we just had a minute ago, but that's not good for determining which specific box I touched, if I did touch any at all. So the function is instance place. Same, I think it's the same everything else, XY object type, but this now checks and returns an ID number for the box that I'm colliding with, or no one if there's nothing in that place. So this is great. I can get rid of this equals true here, because now this returns something, this instance place function, instead of returning true or false, it's returning either this keyword no one, or it's returning basically a pointer, a reference to the instance that it collided with. So if I can say if instance equals or does not equal no one, do this. So let's just try it before we worry about the box. Let's just test this out and say, is he doing the exact same thing he was doing a minute ago? Yes. Good. Okay, very good there. Okay, so we got this working. So if the instance is not no one, then I can continue on, because if it is a no one, like a null pointer, and I try to access a null pointer, my game will crash. So let me just show you. I can comment that out and run the game again, and it shall crash. It doesn't crash? Oh. Anyway, it's never too, you should always be safe. I don't know why that doesn't crash. But anywho, oh, it doesn't crash because we haven't tried to actually physically move the box yet. I'm not going to do it, but trust me, it will crash. It would crash if you do this in a couple minutes here. So the point of this is, I'm moving at a certain speed for a certain amount of time in a certain direction. So I probably should do that also for, this does everything for the player, and I also want to do this for my box. I call it inst dot, inst dot, inst dot. So we can try this out again. So it's always, little baby goose steps. Try this, try this. Look at that box go. Okay, look at that box go, right? But there's no code to stop the thing. That'd be pretty cool if it had friction. If, curling season is coming to an end, but that's not how things go. But at least it's being pushed, right? Which is pretty darn cool. The only thing we have to do is just go back and just set the speed to 0 when the alarm goes off, because we have that going here, right? And so I can do the same thing for my box. I can say, hey box, when your alarm 0 goes off, stop moving. So now, there it goes, right? And now that character can't move anymore because everything has gone according to plan. So that covers everything when it comes to moving the block in one of the 4 directions. So that handles right. Looks like pretty perfectly. So coming back so you can kind of see the code one more time. Hero, press right. There's a lot going on here. I hope I can get it all on one page. There it goes. But it's just the basicness of if there's nowhere to go in front of me, I can walk normally. And if there's a box in front of me and I can push it because there's nothing in front of the box, I can do that. This handles me, this handles the box. All right, so now once you have that working for you, now it's just a matter of going in and changing everything for the other direction. So you can duplicate the event, key press left. And so now I just go, and for this one, it's just instead of x plus, it's x minus. Direction is 180. Same speed and direction, or same speed and alarm. We're going to be using the left sprite. Image speed is 1. And then go back here and go x minus. Direction is 180. Speed is the same. Alarm is the same. Change the sprite to the left. Speed is 1. Direction is again 180. Speed is 2, direction is this. So we don't have any code to test this just yet. And that's the nice part about this, is it's very easy to determine when things go wrong, because you know exactly which press you did, and then you can just go back and fix up, which of the if cases failed. So now I can duplicate this. This is the challenging one, the key press of up or down. So I could say key press of up. And so now the challenge comes here. This goes away because now we're dealing in the y coordinate, and so now it's minus sprite height. So in this case, up is 90 degrees, speed is the same, alarm is the same, we use the same, change this here, image speed is the same. So now I'll get rid of this guy, and I guess I can borrow this. I don't have to type it out every time. So x, y minus sprite height, get rid of this, boom, boom. Y minus 2 times sprite height. Solid, and then again, direction is 90, speed is 2, alarm is 30, use the up sprite. Speed is 1, same thing here for the block, 90, 2, and 30. So that handles up, and then I duplicate this, and it should be pretty easy. Key press down. And now I'm just changing the minuses to pluses and the 90s to 270s and the ups to downs. And if I did this right, it should be pretty simple to see. So let's see, y plus 2 times 270, speed of 2, 0 down, speed of 1, same thing here, 270, 230. So let's try it out. Puzzle 1, move it over here. So forgot I got all these guys working together here. Let's just turn them into one here. I'll just make it easy. Okay, so I can press down, I can go down, I can press left, I can go right, I can go down, I can go up, I can just walk around. Cool, cool. I can go down, oops, I can't go right. I can go down, uh-oh, that is the only problem here. Uh-oh, what happened, right? So the only thing that's happening is if I'm pressing the keys too fast, everything goes to heck, because this animation, I'm resetting the alarm. Every time I press up, if there's nothing or whatever condition is set, I can continue to reset the alarm, which means that if I reset the alarm halfway through my movement, well, then I'm going to go, and I'm not going to end up on a square boundary, because I'm going to go halfway, and then I'm going to go a whole nother one. So I'm going to stop, but I'm going to be halfway in. And so what I can think of is that, basically, if I do press the key, if my alarm is greater than or equal to 0, just return. Don't do anything. I know this is kind of a hack out, but I just to get it out of the way and get it over with. So the alarm is counting down from 10 or 30 or whatever number, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And so if that number as it's counting down is greater than 0, don't do anything. Don't allow that key press to matter. And only if the alarm gets set or the alarm gets alarmed, and does its work, then the alarm will be set to -1 or even 0, and you'll be able to do it again. So this is just a really quick and dirty, not 100% approved, but gets the job done hack so that the character never gets stuck between two squares. Because now you can see that I'm jamming the button, but you can see he's only going square for square. Press left, press down. So left is working, right is working, up, up. I just want to make sure I don't get myself into too much of a pickle here. So down, down. So what else was there? Right. So I think I've done it all. And if not, again, if something comes up later, we can fix that. And I think we've also handled like jamming. Sometimes if you jam two buttons or two keys at the same time, there's things that can go wrong. But I think I've covered this, and I think I've covered everything that can happen. So movement is pretty much well covered. So now what I can do is just consider this done for each of the 4 cases. And so now I can move on to the 2 final steps, is making sure that there's a win condition, and then just basically adding to the number of steps. And that one's pretty simple. Number of steps, that ties into the score value. So if you want to, you could set create, and you can just say, hey, okay, score equals 0. And every time you go in, and this is the cool part here, because you don't have to go in and change the score every single time here. Boom, 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 like something like that. What you can do here is you could just put it in the alarm timer and just say plus plus score. Because every time you move and you complete one full movement, that's when you can just say, I've made one full movement, I've increased my score. I think that's pretty cool. So then to display this thing on the screen, I can just take over a draw GUI event. And somewhere on the screen, I'll just put it pretty near to the top, 5, comma, steps taken, plus string of a score. Let's see if that works. Uh-oh, what'd I do? Oh, I need an extra parenthesis. Oh boy, that font. See, I forgot about that font there, but let's just see if it's... Okay, hold on. It's 6 per person. Hold on a second here. Let me go back. I forgot about all this. Let me go and delete and kill all these. Oops, I'm in the background layer. That's why I can't do that. There we go. Kill them all off. Okay, so now one per movement, please. 1, 2, 3, 4, 5, 6. Okay, cool. So now I just got to fix up the font. Shoot, I guess I'll have to create a font real fast. I'll just use Arial, and I'll call it gameplay font. Arial 20, just use Arial 20 bold. I don't know, just whatever, just something to have it. So now in my hero, now when I draw the text, I can say draw set H-align, because I want this thing to be FA left outlined. I want this thing to be centered, or FA top. When it comes to V-align, draw set color, C, I guess we'll go black, and then draw set font, gameplay font. Oops, gameplay font, and let's see what this does now. Okay, let's see a little better. Maybe black, maybe I'll use white instead, but there you go, steps taken, and now there's my running counter. And so what's cool about this, if you don't take a step, if I'm jamming up and I'm not going anywhere, I'm not getting punished for that. So only when I complete a full step does that occur. So one more time here, just change this to C white. And now we have a step counter. There we go, much better. Okay, so now that's all taken care of. Final step, for this video at least, is to go ahead and add the goals. And adding it to the room itself is trivial. Just go, just drag, just put them in there. So let's see, we got 5 boxes, I'll put 3 goals in here. Okay, so I could do things, there's a lot of different ways I could do this. It might come and bite me later in the butt. But what I'm going to do is I'm going to create an actual controller object for this. I'm going to call it gameplay controller. And its job is just to watch over the winning condition. So the hardest part after, a lot of times I get this every time when I'm teaching in class, and sometimes I forget too, you got to make sure you drag the gameplay controller into the room. And I love to put them just outside the room in the upper left-hand corner because it's very easy to get lost if you put them anywhere else. So this object, it doesn't exist physically, but it's basically watching over the game, basically asking the question, did I win yet? Did I win yet? Did I win yet? Okay, so, and I won when every goal is touching a box. It has to be every goal touching a box. It can't be the other way around, because there's more, in this case, there's more boxes than goals, but the point is to get every goal to touch a box. And so, what I can do is I can set up, this is what we can do here, we can actually set up a custom user event. And I'll show you. Let's just run the code. Let's just create the code, and then I could just, you know, basically here. Let me just show you. Show message. Show message. I did it. So this is so the gameplay controller user event 0. So user events are, if you know, there are 16 of them that you can call up, and they're numbered 0 through 15. They're basically events that you can generate. The game will never generate them on their own. You have to call them yourself. So what I can do to call them is I can do this from the hero. And so when the hero's alarm goes off and he's made the full step and he's done the full push, I can say with gameplay controller, I can say call user event, let's say event user 0. So the with statement is pretty interesting in GameMaker. The with statement says, hey, a minute ago I was in the hero object, but for right now pretend like I'm the gameplay controller object. So everything that happens in the block of code here is basically calling for the gameplay controller. So this is saying, hey, gameplay controller, call event user 0. User event 0. So this will physically call that. So actually right now, every time I take a step, it'll bring up that message. I did it. I did it. So it's working. So now we just have to add the check every single time to see, have we hit a winning condition? So this is pretty cool, and say this is a good place to put this, a nice simple place to put this. So not a lot of code, right? So the final step here in the controller itself now, basically this I did it can just become I did it. I mean, I can leave it alone because you beat the level. But now this is where things get tricky. So just kind of go with me, you know. So what I need to do is I need to set up a variable, and I need to say something like has one is true. So the working theory here is I'm presuming I won the game. Prove to me that I'm wrong. And right now, so this is kind of how things would go. You're like, okay, I just presume I won. You haven't proven anything yet. And then I go, did I win? And you go, yep, I won. Cool. And then I can put this, I did it up there, and then I can do a room go to go back to the main menu. Main menu room. Where are you? Down here. So just to make sure that, okay. So try it out. I take one step and you go, I did it. And then I'm gone, okay. I proved myself right, and now I'm back at the main menu. So now it's my turn here in this, in here to put in the counter example. Try to find a counter example. And if I can't find one, then I have to admit, yes, you did win the game. But for every goal in my game, if place meeting x comma y comma box is equal to false, something like this. For every goal in my game, check to see if they're touching a box. And if any goal is not touching a box, then I didn't win. And just say, hey, my has one property is false, and break out because there's no reason to do any more work. All I need to do is find one counter example. And so the other is here because once you're inside a with statement, you are basically inside that object. And so every variable that you're accessing, the x and the y here in this case, they are based off of the goal object. But if I want to access this variable that I just created here, I have to say other dot, which basically kicks me out of the with statement and finds the variable in the other object, in this case the gameplay controller object, which is right here. But otherwise, this is the example. If I can go through and every single goal is touching a box, then I never set this thing to false. I fall through and I go, yep, I did do it. I did win. But if I find any counterexample, then it continues the game. So here, so it's going to take just a little bit, but you get the point. I said we'll fix up everything later. If anything is off with depth ordering, whatever, that'll be part 3. But there we go. We're getting closer. I just got to make sure I don't screw it up. Okay, and now one more step, right? And there it is. And there, I did it. Because every single goal object is touching a box. So that code handles that case perfectly, and now I go back to the main menu and I can do whatever it is I wanted to. Play the game over. You know, I don't have anything to escape out again. We'll fix all that up in step 3. It's been 31 minutes here for this video. I think we've had enough for today's lecture here. So that pretty much covers everything I wanted to cover here in the video. I wanted to talk about moving around. Just moving. I wanted to talk about pushing. I wanted boxes around. I wanted to keep track of how many steps we took, and I also wanted to determine when the game was won. We've done all of that, and then in pretty simple fashion. Not a lot of code. That's the best part. We used GameMaker, a lot of what GameMaker is good for, to make this thing work. So one last time, I could try just to make sure it's different boxes or just anything like that. Just if that means anything to you. But everything's looking great. So I'm Bradley Sward. Thanks for hanging out with me for this half hour. Send me any questions if you've got them. And next we'll just kind of do the one last cleanup. And then we have the fully working game. And then we're ready to start porting and start moving over and explaining a heck of a lot of what to do in C++ and SFML and making our game engine. So thanks again for playing around. And we'll see you next time.